Hello students, the purpose of this video is it is a continuation of the discussion of parent functions and their transformations. And in this video, we are particularly looking at non-rigid transformations. So in our last video where we talked about rigid transformations, we said that those are movements like up, down, left, right, or reflections where the location of the item or the function is different and it changes, but the actual shape of the graph does not change at all. Well, in a non-rigid transformation, there is shape distortion. So the shapes of the graphs are going to either grow or expand, and they can do so in a vertical or horizontal movement. And so the words that we tend to use are a vertical stretch and a vertical shrink, or a horizontal stretch and a horizontal shrink. If I am performing a vertical stretch, well, actually, I'm going to take that back, that phrase. I'm going to say if I am performing some type of non-rigid transformation in a vertical direction, I know that my function is going to be some number, we'll call the number A, multiplied to the outside of my parent function. And that is true for both of these, a stretch and a shrink, that my A value is multiplying to the outside of my function. Whereas if I'm doing a stretch or shrink in a horizontal direction, I am going to multiply some number like A to the inside of the parent function, okay? And again, that is true for both. So then if they are the same, how do I tell the difference between the stretch versus the shrink? Well, I actually have to look at the value of A. If my value of A is greater than 1, I have performed a vertical stretch as long as A is being multiplied to the outside of the parent function. But if the value of A is between 0 and 1, so that's a fractional value between 0 and 1, then I am a vertical shrink. However, it is the opposite for horizontal. For a horizontal stretch, the value of A must be between 0 and 1, and for a horizontal shrink, the value of A must be greater than 1. So what I always tell people is kind of notice how, A is greater than 1 goes with a vertical stretch and it goes with a horizontal shrink. So they're kind of like across from each other in this diagonal direction. And then vertical shrink is between 0 and 1, whereas a horizontal stretch is between 0 and 1. So again, they are diagonal from one another as well. So if you get into a habit of writing, vertical stretch, vertical shrink, horizontal stretch, horizontal shrink in this format, written like this, it's just a good way to help you remember about movement. But one thing I do want to mention is, remember in our last video we talked about vertical movement, like up and down, or reflections across the x-axis were always on the outside of our parent function. Well, the same thing here. My A is being multiplied to the outside of the function if I'm in a vertical direction. Whereas horizontal movements like left to right, or reflections across our y-axis, or in this case, horizontal stretches and shrinks, my value of A is being multiplied on the inside. So it's just a nice, helpful, quick, easy way to remember the respective formulas. So one thing that I would like to kind of help you with is the steps to graphing. So I'm kind of freehanding this. I'm not being very formal here, but if you are trying to graph multiple transformations, the first thing you want to do is graph your horizontal shifts. So that represents any left to right direction. So if your graph moves left to right, you'll graph that first. And then you would want to start by doing any shrinks or stretches, whether that's vertical or horizontal. And then you would start by doing, or I guess third step would be reflection, whether that's across X or Y axis. And then you would do your vertical shift up or down. Okay, so you won't really have to be graphing, but this is something that I just wanted to share with you in case you run across this. So before I end this video, I do want to look at some examples. So let's say that I am going to deal with a rational function. So we know that the parent function for a rational, is 1 over x. And let's say that I want to perform a vertical stretch, and let's do it by 3 units. That means I am taking the parent function, 1 over x, and I am multiplying it by 3. This is one way you could write your answer, or I could actually go through and multiply this and get 3 over x. Now, let's say that I wanted to do a horizontal shrink by 3 units. Then I would want to multiply the 3 to the inside of the function. And the part that makes me understand what this function is my fraction over x. And so I'm going to want to place that 3 with the x. So if I'm doing horizontal movement, I know that that value needs to appear in my denominator. Let's say that I had the parent function of a square root of x, so the square root function, and I wanted to do a vertical shrink by 1/2. Then I literally could just write 1/2 times the square root of x. And I don't have to put those parentheses, but I can. Whereas if I wanted to do a horizontal shrink let's see, for a vertical shrink, I would have to be bigger than 1, so by 5 units. Then I would have the square root of x, but again, what makes this function is having the square root and this x, so I would want to be within that, and I would put my 5 next to the x. Okay? Alrighty, as always, I hope you found this video helpful. If you have any questions and concerns, please don't hesitate to reach out, and I hope you have a good rest of your day.